Hi, friends. I hope you had a great weekend. Sorry, I don't know what's happening here. Let me try this, change this a little bit. Okay. Here we go. We are going to do Unit 9, Lesson 3. And then you're going to have an assignment over here. So I'm going to go over the notes with you, and then I'm going to go through one of the problems from the assignment, and then you should be good to go for today, okay? All right. So uh, we are looking at growth and decay. Whenever we have exponential equations, these equations look like L's, and they're either increasing as we go from left to right, or they're decreasing as we go from left to right. Okay. So if they're increasing, we call this growth. It's going up. If they're decreasing, we call it decay. And you've probably talked a little bit about growth and decay in your biology class when you talk about population. So if like rabbits have a very rapid growth in population, rabbits multiply very quickly, okay? Decay, if you think about like the dinosaurs, we had a bunch of dinosaurs on the earth at one point, something happened and they all died off and they're extinct now, right? So they decayed. There's not as many of them anymore. So growth, when we're talking about an equation, our A value is our initial value. This is where we start. So how many animals did we start with at the beginning before the population started growing? B is going to be our growth rate. And this is going to be a number bigger than 1. It's going to be a number bigger than 1. Okay? So B represents our growth rate, and it's usually a number bigger than 1. If you're looking at an equation and your B is bigger than 1, then you're talking about growth. If it's smaller than 1, between 0 and 1, then it's going to be decay. All right, so again, I'm going to kind of do both of these. I think I'm going to do each box at a time. So decay, when we talk about decay, A again is still our initial value. So it's how many did we start with? And then B is the decay rate. And this value is going to be less than 1. It's going to be between 0 and 1. Okay, so if you have 1/2 or 0.5 or 0.7 or 0.8, 1/8, all these things are between 0 and 1. This is going to be decay. It's going to cause the population to decrease. Okay, so real world example. I think I'm going to work my way around the table. We're going to start with the table. So we're going to write a rule for the function. We have this table. When we write rules using a table, I want you to use your calculator. Do stat edit, okay? We're going to write equations using stat edit. If my calculator will load, here we go. Okay. So hopefully you guys at home are becoming pretty comfortable with stat edit. Second plus 712. Why did I clicked stats. Second plus 712 clears out the calculator. Hopefully you're becoming pretty comfortable with stat edit. We've used it quite a bit over the last few weeks. Okay, so when we do stat edit, our x values go in L1, our y values go in L2. So I'm going to do -2, -1, 0, 1, and 2 go in L1. Then we're going to go over to L2, and I'm going to do 1 divided by 8 is 1/8. 1 divided by 2 is 1/2. 2, 8, and 32. And we can do stat, go over to calc, go down to quad reg, and hit enter. We're going to go down to calculate and hit enter again. And we can write this this equation. Oh, ooh, Miss Green, Lena, pay attention. Okay, calc, we're doing exponentials. We are not doing quadrig. I need to go all the way down to 0. Hopefully y'all caught that error and you did it correctly. Okay, exponential regression. And then we're gonna go down to calculate. Here we go. Okay, now this looks much better. We have an a and a b. This gives me the exponential equation right here, right? A times b to the power of x. So the rule for this table is going to be y equals a is 2 times b is 4 to the power of x. Okay, so this is my rule. We notice how b is bigger than 1, so this is growth. Okay, we can see on our table that 1/8 grows to 1/2. 1/2 is bigger than 1/8. 2 is bigger than 1/2. 8 is bigger than 2, and 32 is bigger than 8. So we can see that our y values are increasing, okay? So this is another way we can see for exponential growth on a table. If you're asked, does this table represent growth? You can say yes, because all my y values are increasing. All right. So I guess we'll look at the decay. We'll go ahead and do the table for decay right now. Okay, so now we have a table for this. We're going to come up with a rule for this table. And when I'm looking at my y values here, it goes 81, 27, 9, 3, 1. So my numbers are getting smaller. Because my numbers are getting smaller, this is decay. So I can put this in my calculator again and come up with the rule. A rule just means, what's the equation? When saying what is the rule, we need an equation. So let me move this way so I can see it. So we have -2, enter, -1, enter 1 and 2, so that my x's didn't change. I'm going to go over and change my y's out. We have 81, 27, 9, 3, and 1. And then we can do stat, go over to calc. We can go down to exponential regression. And we can go down to calculate and hit enter. And again, this tells me my rule is y. I don't know why that came all the way over there. Y equals, my a is 9 times. Really quick, I want to show you guys again. I think I've showed you before. We can take this 0.333 and turn it into a fraction. So I'm going to go to my home screen by doing second mode. I'm going to do this calculator in here is so slow. 0.3, and I'm just going to type in 3's until it goes across the screen. Because those 3's are just going to repeat. That's what that meant. And then I can do math, enter, enter, and it will convert that to a fraction for me. So this is 1/3. So instead of writing 0.333 repeating on this on my assignment, I'm going to do 1/3, and this is being raised to the power of x. Okay, so it's decreasing. This is decay. My b value here is smaller than 1. So again, I can see in the equation that it is decay. All right. Now I'm going to look at my graph. So my graph, we have a graph that's going up. That means it's growing. It's getting bigger. For decay, it's going down. Do we see from left to right? It's going down. So that's decay. We learned on Friday how to write an equation for these. So we're going to write a rule for this function. I'm going to pick some points on here and make a table. So my table over here, I have x's and y's. I'm just going to pick 2 points. I have, let's see. It looks like these are 1, 2, 3. So we've got a point at -2, 1, and another point here at 0, 5. 0, 5. So I'm going to do stat, go over to stat, edit. I'm going to have to clear out my calculator first. Second plus 7, 1, 2. I'm going to do stat and edit. I can type this in, -2, enter, 0, enter. We can go over here and do 1 and 5. Stat, calc, and exponential regression. Go all the way down to calculate. All right. So we have our equation would be y equals 5 times, and that makes sense. My y-intercept is my a value, so that's where we cross the y-axis. 5 times, and we have 2. I'm going to write this in and change it to a fraction, I think. 2.236067977. So I'm going to convert that to a fraction. Let's see what it gives me. 2. My calculator's getting on my nerves. I really don't like using it on the computer. Okay. 236067977. We're going to do math, enter, enter. And it didn't convert it. So we'll just round it. We'll say 2.37 to the power of x. This number is bigger than 1, so it is growth. Okay, so this is the rule. So on a graph, you can look and see, is it increasing? Then it's growth. On a table, you can look and see if my y values are increasing, then it's growth. Okay, so down here on decay, we can see that the graph is decreasing, so it's decay. Again, we can pick some points here. So we have x and y. We have a point at 0, 4, and another point here at 1, 2. So we know we're going to have y equals my a value is going to be 4, I believe, because that's where we cross the y-axis. So I'm going to do stat edit. I'm going to come over here and I'm going to do 0, enter, 1, enter. And over here, I'm going to do 4, enter, and 2, enter. We'll do stat, go to calc, come down to exponential regression, and come down to calculate. All right, so it tells me my a value is 4, my b value is 0.5. 0.5 is the same thing as 1/2 raised to the power of x. 1/2 is smaller than 1. This is decay. Okay, so when we have growth, my b value is bigger than 1. We have decay, my b value is between 0 and 1, and now we've seen that in all these cases. So let's look at the word problem, real world examples. And this is a little bit different because we're going to learn how to write some word problems here. Write equations from word problems. And then we're going to practice writing these equations a little bit more tomorrow, okay? All right, you deposit $4,500 in an account that pays 5% interest compounded annually. Write an exponential function to model this scenario. All right, so we said that our A value was our initial value. Our B value is our growth rate. So in this problem, we deposit $4,500 into an account. So $4,500 is my A value. That's how much money I'm starting with in my account before it starts a compounding interest. Okay. Then it's growing. It says the account that pays interest, 5% interest compounded annually. So that pays interest, that means it's giving me money. I'm gaining money on top of my $4,500 while it's in this account. And it's coming in at a rate of 5%. So my B value is that 5%. I can't put percentages into my equation. So I want to convert this to a decimal. So my decimal, if I convert this, I'd have to move my decimal over 2 places. So 5% is the same thing as 0.05 as a decimal. 0.05. Remember, I have to move it 2 spaces. And I don't want to just keep this as 0.05 because I'm not going to take, let me show you in my calculator. I'm going to show you this again in my video tomorrow. In my calculator, if I did 4,500, because my equation right now, what I'm thinking is my A value is 4,500. times my B value is 0.05, right? So if I do 4,500 times 0.05, what this says is that I'm going to have $225 in my account after the first day. So am I going to lose all that money from 4,500 down to 225? No, that's not the case. What's happening is I'm going to take my 4,500 and I'm going to take this 225 together. So my rate is going to be 1 plus the percent. Whenever I have a percent, I want to add 1 to it if it's growth. If it's decay, we're going to subtract 1 from it, okay? So we're going to do 1 plus 0.05, so we'd have 1.05. So my equation would be 1.05 to the power of x. So let me show you what that looks like. 4,500 on one day would be times 1.05 equals 47.25. So what this did was it took my $4,500 that I started with and it added that $225, which is just the interest I'm earning. Okay, but it added it together, and now it's telling me I'm going to have $44,725 in my bank account after day one. I've gained that much money on the first day. Okay, so this is how we want to write the equations. Again, we can't have a B value for growth. I can't have a B value that's less than 1. So I had to add that 1 to it to give me growth. Okay, so then decay. Hold on, guys. What is happening? Here we go. A word problem for decay. A car was purchased for $18,000. The car depreciates by $20,000. The car depreciates by 20% each year. Write an exponential function to model this scenario. So what's happening here? We're buying a car and it depreciates. The word depreciates means it loses value. Okay, so it's losing value. As soon as you buy a vehicle, you drive it off the lot, it's going to lose value. It's not going to be worth as much as you just paid for it. Okay, so this is losing value at 20% each year. So my A value, my starting price was $18,000 for this car. My rate, my depreciation rate, the rate at which the value is decreasing, or my decay, my B value is 20%. Okay, so remember, we want to take the initial value and we want to subtract off the 20%. So I want to do 1 minus, and we're going to convert this to a decimal, 0.20. So when I do 1 minus 0.20 and hit enter, I'm going to be left with 0.8. So my depreciation value, the B value I want to use, is 0.8. This is smaller than 1, and this is going to tell me how much my car costs each year after the depreciation has happened. So we're going to do y equals, my A is 18,000 times 0.8 is my depreciation value to the power of x. So what this tells me is how much money am I going to lose? So in year 1, if I put a 1 up here, then this would just stay 0.8. So I could go 18,000 times 0.8. So after the first year, my car's only worth $14,400. Okay? All right. So now let's look at the assignment. So you should have this assignment, Growth and Decay of Penguins. For those of you that are in person, at this point, we're doing a different assignment in class, but it's the same concepts, okay? We just have it on paper, so it's different. Okay, so king penguins, here we go. I'm going to do the first one with you, and then I'm going to let you guys do the rest, okay? The population of king penguins living on an island near New Zealand increased at a rate of 3.9% per year on average between 1930 and 2010, from a count of 3,400 penguins in 1930. Okay, so determine the initial value A. So there's a lot of stuff going on here. But what I want to know is, how many penguins did I start with? Well, it said from a count of 3,400 penguins in 1930. 1930 is when we started. So in A, is it going to let me type here? I'm going to write 1930. We had 3,400 penguins. Let me stop mirroring. Maybe that will help. Okay. So then we're going to determine whether the situation represents exponential growth or decay. So are we growing things? We're going to drag this little circle. Are we growing or are we losing? Are we increasing or are we decreasing? So it says right here, I see it popped out at me. The population of king penguins living on an island near New Zealand increased. So increased means growth. So growth, we have growth. And they increased at a rate of 3.9%. So I'm going to type in 3.9. And I'm going to do shift 5 will give me that little percent. So 3.9%. So now we want to formulate the equation. So our initial value is that 3,400. So we have 3,400. And our rate increase is going to be 1 plus the percent. So I have to move this decimal over 1, 2, so that'd be 0.039. And we're going to add 1 to that. So if I add 1 to 0.039, it's going to be, let me tap that in my calculator so you guys can see. So we're going to do 1 plus 0.039 is that percent as a decimal. And I get 1.039. So my rate is 1.039. 39. Here we go. Okay, so now we're taking it one step further here, okay? If the trend continues, what will the population be in 2030 according to the model? So this equation tells me the population since 1930 after X number of years, okay? So I need to reconnect this so I can kind of walk you through this a little bit. There it is. Okay. Here, I'll put it over here. Okay, so my equation is y equals, let me write it. There you go. Y equals 3,400 times 1.039 to the power of x. X is going to represent the number of years since 1930. Okay, so what I want to know is what's the population going to be in 2030? So how many years since 1930 is that? Well, if I do 2030, oops, let me do it down here. 2030 minus 1930, that's 100 years. So that means I want to know when x is 100, how many penguins are there? Okay, so I'm just going to plug in x. I want to know when x is 100, what does this equal? What does y equal? So on my calculator, I'm going to put this in my calculator just like this. So I'm going to do 3,400. It didn't type in anything. 3,400 times 1.039, and we're going to raise that to the power of 100. How many penguins do we have? Let's see, 155,967. We're going to knock it. These decimals don't count as penguins. They're still little baby eggs or something, okay? So we're not going to count those. So we're going to write in here. Ooh, I guess I need to write that down. Let me pull my calculator back up. 155,967. So over here, I've got 155,967. That's how many penguins we have. Okay, so you might have to pause my video and go back and do each step one at a time, but I want you to do the rest of the penguins. So you have these Adelaide penguins, Gintu, little penguins. You got a couple more, 5 more pages. 5 more pages to do, okay? So finish this up, turn it in, make sure you go back to Canvas, hit submit. Tomorrow, we're gonna have an assignment where we're just writing. You're not gonna have to do the solving part, all right? Y'all have a good day. Remember, you have to come take your STAR test on Wednesday, not STAR test, benchmark, Algebra 1 benchmark on Wednesday. Make plans to be on campus on Wednesday. If this is an issue, please email me. I sent you a message in Canvas. I sent you an email. I think that's all I've done. But if you cannot come, let me know so we can make other arrangements. All right? Y'all have a good day. I'll see you tomorrow.